Earlier, we learned how to find or determine whether a value or a factor is a solution to a polynomial. Now we're going to find all of the rational zeros of a polynomial. So we need to use synthetic division over and over again until we find the numbers that leave a remainder of 0. Well, how do we know when to stop? Or how do we know if we found them all? Well, there's a theorem that states that if you look at a polynomial function and you look at the constant term, that's why we said these earlier, and we think of all the factors of that constant term. So in this case, the factors of 8 are 2 times 4, or 1 times 8. So these are all the factors of 8. So one of the possible solutions could be positive or negative 2, positive or negative 4, positive or negative 1, or positive negative 8. That's what the rational root theorem says. There's also something dealing with the leading term, or the number in front of the leading term, or the coefficient of 3. It also says that all of these divided by all the factors of that leading term could be a possibility. So we have 2 divided by 3, 4 divided by 3, 1 divided by 3, and positive and negative 8 divided by 3. These are also possibilities. Other factors of 3 are just 1, and these are all over 1 originally. So these are all the possible rational roots of this polynomial. Now, if we did that, that would take an awful long time to do each one of those, to do it individually. So luckily, the calculator has afforded us to find these solutions a lot quicker. So grab your calculator. So I have my calculator here, and in number 1 below, we're going to find all of the roots of this polynomial equation. Now we know the possible roots are 1, 2, 3, and 6, positive and negative. So I'm going to type into my calculator, turn it on, and type into the y equals, I'm going to clear what's in there, this equation. So x to the third plus 6x squared minus 13x minus 6. Whoops, as you can see, I messed up. So let's try it again. X to the third plus 6x squared minus 13x minus 6. Now, what I want to do then is use my calculator table to check all possible roots. So I'm going to look at 1, 2, 3, and 6, positive and negative, and see if my y is 0. So I'm going to hit second table to look. Now, if you're at a different location, you might have to page up to it or down. Since there's no a value in front, I know they're all going to be integer values. So if you look at the calculator, you can see that there's 1 at 2. That's the only one that I can find, because I just have to go up to negative 6 at the lowest. So here's my first solution right there, 2, 0. My y is 0. So I'm going to write down that my solution is x equals 2. So once I find one of them, I can then use synthetic division to find the others. So I'm going to put my 2 in the box, put my coefficients across the top, and perform synthetic division. Bring down the 1. 2 times 1 is 2. Add to give me 8. 2 times 8 is 16. Add to give me 3. 2 times 3 is 6. And I get a remainder of 0. So I have x squared plus 8x plus 3 as my polynomial. Now, the first thing I want to do to find the other zeros is, does this factor? Are there factors of 3 that add up to 8? No, there aren't. So to find the other two x values in this quadratic, I need to use the quadratic formula. So x equals negative b, so negative 8, plus or minus the square root of b squared, which is 64, minus 4 times a, which is 1, times c, which is 3. All divided by 2 times a, which is 1, so all divided by 2. So I know that I have negative 8 plus or minus, this is 12. So I'm going to grab my calculator, quit out of this, and take 64 minus 12, and it gives me 52. So it's the square root of 52 divided by 2. Now, if 52 simplifies, I'm going to see, does 52 divide by 4? It does. So negative 8 plus or minus, because this is 52 is 4 times 13. I can take the square root of 4 to give me 2, but I can't take the square root of 13. All divided by 2. So my other two solutions are this simplified. You can take 8 divided by 2 to give me negative 4, plus or minus. 2 divided by 2 gives you 1, root 13. So my other two solutions are negative 4 plus root 13 and negative 4 minus root 13. These are all the real solutions because they are real numbers. So let's try it again. Find the real zeros. So we know that we're going to have 4 because this is a degree of 4. And so we know the solutions are going to be, again, 1, 2, 4, or 8. So let's type this into our calculator. I'm going to clear that off. X to the 4th minus 9x cubed plus 24x squared minus 24x plus 8. So again, second and graph to look at my table. So looking at my table, I'm looking for values. So I can see 2 of them right here. 1, so I know x is 1 or 2. So let's go clear up to 8 to see if I see any more places where y is 0. And let's go down to negative 8 to see if I see any there also, which I don't. So those are my two solutions. So I know that I have 4, so I need to do synthetic division. So I'm going to, let's pick either one. Doesn't matter which one you start with. So pick either one. We'll pick 1 and do synthetic division. X to the 4th, x to the 3rd, x squared, x, and 8. Bring down the 1. 1 times 1 is 1. Add. 1 times negative 8 is negative 8. Add. 1 times 16. This is a negative 24. Something seemed weird for me as 16. So negative 24, you can use your calculator or you can do it in your head. We get negative 8, and 1 times negative 8 is negative 8, so we get a remainder of 0. Now this is the tricky part. So this still gives me a cubic third. So I need to divide now by the second one using these numbers. So bring down the 1. 2 times 1 is 2, negative 6. 2 times negative 6 is negative 12. 4. 2 times 4 is 8, 0. So now I have a quadratic of x squared minus 6x plus 4. So I can find my other two solutions by factoring. If there were factors of 4 that added to 6, which there aren't, or now we need to use the quadratic formula again. So x equals negative b, which would be positive 6, plus or minus the square root of b squared, which is 36, minus 4 times a, which is 1, times 4, so minus 16 divided by 2. So we know that 36 minus 16 is 20. And 20 simplifies to 4 times 5, so we're going to get 6 plus or minus the square root of 4 is 2 root 5 over 2. So again, 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, root 5. So our two additional solutions are 3 plus root 5 and 3 minus root 5.